This lecture is on how to read and interpret the periodic table, which is a tool that all chemists use to help them understand and organize elements into their properties. The first thing I want you to notice about this periodic table is that the elements have no names. They just give you the symbols. Therefore, on the test, you will have to know probably the names of the first, I'd say, 40 elements. You'll probably also be expected to know the names of all of these two groups. Okay, these are what we call the representative elements. So they could probably pull up any of these elements at any point in time on the test. The next thing I want to talk about are the boxes that represent each of the elements. Okay, should be review. Remember that the top number represents the atomic number. All the atomic number is always defined by the number of protons that an atom has, but in a neutral atom, it represents the number of protons and the number of electrons and of that atom. The next thing is the chemical symbol. Again, you'll have to know the chemical symbols for the representative elements and probably the first 40. And then the last thing is the average atomic mass, which on this periodic table represents the average masses of all the isotopes of that atom. Usually, though, remember that the atomic mass of any atom is the number of protons plus the number of neutrons, because those are the only two subatomic particles that have mass. Next, we're going to talk about the three different types of elements that we can find here on the periodic table. Okay, the first type and the major type of elements I'm outlining here in purple. These guys are the metals. Okay, you can see that most elements here on the periodic table are metals. Metals tend to act as cations. They tend to be shiny, have a luster, they can conduct electricity, okay, amongst other properties. The next types of elements we're going to look at are these guys along this staircase. So if you remember the staircase from regular chemistry, let's see, germanium gets in there, boron, silicon, germanium, antimony, let's see, acetate, I believe that is, bismuth, polonium. Okay, these guys are what is known as the metalloids. Metalloids, notice they're on the diagonal. They tend to act like both metals and nonmetals. Okay, they're crushable like metal or like nonmetals, but they conduct electricity like metals. These guys are often used in computer pieces, especially silicon. Okay, and then the next type of element are the nonmetals. These guys here in blue. Okay, the nonmetals tend to have a variety of types of states of matter. We have gases, solids, liquids, but they tend to not conduct electricity, and they tend to form molecular compounds with each other, whereas metals and nonmetals form ionic compounds. Okay, this slide goes a little bit more into depth of the names of the different types of elements. Okay, so again, the first column or the first group are called the alkali metals. Okay, everything in this group tends to behave the same. We can see that the number of the group on top of the column is 1. That represents the number of valence electrons. So all these atoms have 1 valence electron, so they tend to behave similarly. Same with the alkali earth metals. They all have 2 valence electrons. Okay, we then skip over the transition metals and we go to column 13 or 3A. They have 3 valence electrons. 4A, 4 valence electrons, 5A, 5 valence electrons, so on and so forth. Okay, so we've got the alkali metals. Notice I have hydrogen there in pink. Hydrogen is not a metal. However, it has metallic properties because it has that one valence electron, so it does behave like the other alkali metals. Then you've got group 2 is the alkali earth metals. In the middle you have your transition metals. Okay, at the far end, group 7A or 17, those are the halogens. And then the last group in kind of the pinky, or sorry, the orange color are the noble gases. Those have 8 valence electrons. These are the elements that are relatively stable and therefore really don't react too much with other elements in there. Their electron configuration is what other elements do, or other elements behave such that they get valence electron, or they get electron configurations like the noble gases. We can call it the octet rule. Okay, we've got the other nonmetals: carbon, nitrogen, oxygen, phosphorus, sulfur, selenium, and hydrogen. Those guys are nonmetals. And then boron, silicon, germanium, astatine, antimony, tellurium, and polonium represent the metalloids, which behave like a little bit like metals and a little bit like non-metals. The last slide is going to talk about the charge of the ions formed by the elements in these columns. You can see that column 1A, again, we talked about this already, that all columns kind of behave, or all the atoms in each of the representative elements columns kind of behave to become like a noble gas, meaning that they either gain or lose electrons to maintain a noble gas electron configuration. So all the atoms in the first column have 1 valence electron, so they are going to lose that 1 valence electron to become like the noble gases, therefore forming a +1 ion or cation. The second column, the alkali earth metals, all of those have 2 valence electrons, so they are going to lose those 2 valence electrons to become like the noble gases, thus forming a +2 charge. We skip over the transition metals, though their electron configurations are a little bit more complex because they move into the d orbital. So you can't predict all of them. You can predict some of them, but we're going to skip over again just to the representative elements. Most of the elements in column 13 or 3A form a +3 charge. Column 4A, you can see it's either, we're kind of counting up and then counting back down. So these guys are +4, -4, but the elements in this column can form a couple different types of ions. So we'll talk about those as we come across them. I want to point out that carbon here, carbon has its own chemistry. Carbon is the study of carbon and the compounds it forms is called organic chemistry. Carbon is a very interesting element, so we can't really predict its charge here. And it mostly forms molecular compounds, not ionic compounds. Okay, then with nitrogen, these guys have 5 valence electrons, so really they are closer to the noble gas configurations by gaining electrons rather than losing electrons. So all these guys in 15 or 5A tend to gain electrons with a -3 charge. 16 or 6A, these guys need to gain 2 electrons, so they gain, or they generally have a -2 charge. And the halogens, they have 7 valence electrons. They're only 1 electron away from getting that noble gas configuration, so they tend to form ions with a -1 charge. So this was a lecture on the periodic table. We'll talk about it a lot more, but this kind of introduces all the main parts you need to know.